Machine guns changed the shape of warfare long before tanks, aircraft, or missiles became the symbols of modern conflict. They were the first weapons capable of delivering continuous, overwhelming firepower from a single position. And once they appeared on the battlefield, nothing was ever the same again. The story of machine guns is not just a story of technology. It is a story of how armies adapted, how tactics evolved, and how the battlefield itself was forced to transform. It is a story of weight, heat, recoil, and endurance. A story of weapons that could fire faster than soldiers could react. And faster than commanders could plan. But machine guns did not begin as the sleek, efficient systems we know today. Their evolution spans more than a century, from water-cooled giants that required entire crews, to the blistering speed of World War II icons, to the modern general-purpose workhorses that dominate today's conflicts, to the heavy guns that can tear through vehicles and aircraft, and finally, to the classified systems that exist only in shadows. This is the evolution of automatic fire. These are the 5 levels of machine guns, and the secret level 6 that pushes beyond what is publicly known. The first generation of machine guns emerged in the late 19th and early 20th centuries. They were heavy, complex, and often unreliable, but they introduced a concept that would change warfare forever: sustained automatic fire. Level 1, Early Machine Guns. The Maxim gun, Lewis gun, and Browning M1917 machine guns. The Maxim gun was the first true machine gun, not a rapid-fire rifle, not a manually cranked weapon, but a fully automatic system that could fire as long as the trigger was held and the ammunition kept feeding. It was the moment when firepower stopped being limited by human endurance and became a mechanical force of its own. It used the energy of each shot to cycle the action, a revolutionary idea at the time. Every bullet fired created the power needed to load the next one. No hand cranking. No manual cycling. No pauses except to reload belts or refill the cooling system, for armies used to single-shot rifles and bolt-action volleys. It was a weapon that seemed almost unnatural. The Maxim was water-cooled, wrapped in a thick jacket that prevented the barrel from overheating during long bursts. As long as the crew kept the water boiling and the ammunition belts flowing, the gun could fire continuously. Hundreds of rounds per minute, hour after hour, in an era when most soldiers still carried rifles that fired one shot at a time. The Maxim could unleash the firepower of an entire platoon from a single position. The Lewis gun represented the next major step in the evolution of automatic fire. Where the Maxim gun was powerful but immobile, the Lewis gun introduced something armies had never truly seen before: a machine gun that infantry could carry into battle. It was lighter than the Maxim, though still far from light by modern standards. Its distinctive barrel shroud, a long-ribbed cylinder that wrapped around the barrel, helped dissipate heat without the need for water cooling. This made the weapon far more practical for mobile operations, where crews could not afford to haul water cans and heavy tripods across the battlefield. The top-mounted pan magazine gave the Lewis gun its unmistakable silhouette. Each magazine held a circular stack of rounds that fed downward into the action. It was not as fast to reload as a belt-fed system, but it allowed the gun to operate independently, without the long cloth belts that earlier machine guns required. This made it ideal for advancing infantry, aircraft, and early armored vehicles. The Browning M1917 was the moment when machine gun reliability stopped being a goal and became an expectation. It was a weapon built not just to fire, but to keep firing hour after hour, belt after belt, in conditions that broke lesser designs, where earlier machine guns struggled with overheating, jamming, or fragile components. The M1917 delivered something armies desperately needed: consistency. The gun earned a reputation for reliability in some of the harshest environments of the First World War. Mud, rain, and freezing temperatures caused other weapons to seize or fail. But the M1917 kept working. Its simple, robust design allowed crews to clear malfunctions quickly, and its water cooling system prevented the catastrophic overheating that plagued air-cooled guns during prolonged engagements. Level 2, World War II icons, MG42, M1919 and DP28 machine guns. The MG42 was not just a machine gun. It was a turning point. A weapon that redefined what automatic fire could sound like, feel like, and do on the battlefield. When it appeared in World War II, it shocked Allied soldiers not only with its speed, but with the psychological impact of its presence. It was a weapon designed for one purpose: to dominate. Its rate of fire was unlike anything the world had seen, up to 1/500 rounds per minute, more than double the speed of most machine guns of the era. Instead of individual shots, it produced a continuous ripping sound. A harsh mechanical roar that echoed across forests, fields, and ruined cities. Soldiers described it as tearing canvas, as ripping cloth, as something inhuman. It was a sound that carried fear long before the bullets arrived. But the MG-42's legacy is not just technical, it is psychological. Allied soldiers learned to recognize its sound instantly. They knew that when they heard that ripping roar, they were facing a weapon capable of overwhelming firepower. It forced them to adapt, to move differently, to respect the danger of open ground. It shaped their memories of the war, long after the fighting ended. The Browning M1919 was the machine gun that carried American firepower from the trenches of the First World War into the mechanized battlefields of the Second. It was the bridge between eras, a weapon born from the reliability of the M1917, but adapted for a world that demanded mobility, versatility, and endurance. The weapon's simplicity was one of its greatest advantages. Its recoil-operated mechanism was robust and easy to maintain. Crews could strip, clean, and repair it quickly, even under fire. Ammunition belts fed smoothly, and the gun's design tolerated dirt and debris that would cripple more delicate systems. After the war, the M1919 continued to serve around the world. It appeared in Korea, Vietnam, and countless regional conflicts. It was adopted by dozens of nations, modified into new variants, and adapted to new calibers. Its longevity was not an accident. It was the result of a design that valued practicality over complexity and reliability over innovation for its own sake. The DP-28 was one of the most recognizable machine guns of the Second World War. Its distinctive pan magazine, mounted horizontally on top of the receiver, gave it a silhouette unlike any other weapon on the battlefield. But the DP-28 was more than a unique design. It was a machine gun built for the harshest conditions imaginable. The Soviet Union needed a weapon that could survive mud, snow, sand, and neglect. A weapon that could be carried by infantry across vast distances, fired in freezing temperatures, and maintained with minimal tools. The DP-28 delivered exactly that. It was simple, rugged, and remarkably tolerant of abuse. The DP-28 was not a high-performance weapon, its rate of fire was moderate. Its barrel could overheat during long engagements. Its magazines were fragile if dropped. But it was dependable, and in the brutal conditions of the Eastern Front, dependability mattered more than perfection. Level 3, Modern General-Purpose Machine Guns. M240, PKM and FN Mag machine guns. The M240, known internationally as the FN Mag, is one of the most respected general-purpose machine guns ever built. It represents the point where reliability, accuracy, and endurance converged into a single design. A weapon trusted by some of the most advanced militaries in the world. It fires the powerful 7.62 NATO round, giving it the range and penetration needed to dominate open terrain. Its long-stroke gas piston system is robust and consistent, capable of functioning in environments that destroy lesser weapons. Sand, mud, rain, and extreme temperatures have little effect on its performance. It is a machine gun built for the realities of modern warfare, not the controlled conditions of a test range. One of the M240's greatest strengths is its versatility. It can be fired from a bipod as a squad-level support weapon, mounted on a tripod for sustained fire, or installed on vehicles, helicopters, and naval platforms. It appears on tanks, armored personnel carriers, patrol boats, and aircraft. Wherever modern militaries need reliable automatic fire, the M240 is there. The M240 has served in conflicts around the world, from the deserts of the Middle East to the mountains of Afghanistan. It has supported infantry patrols, defended outposts, and provided covering fire during some of the most intense engagements of the modern era. Its presence is a constant reminder of the importance of sustained, accurate automatic fire. The PKM is one of the most widely used machine guns on Earth, a weapon known not for refinement, but for ruggedness. It is the Eastern counterpart to the M240. But its design philosophy is entirely different. Where the M240 embraces weight and stability, the PKM embraces simplicity and speed. It fires the 7.6 254R cartridge, a round older than most modern militaries, yet still powerful and effective. The PKM's long-stroke gas piston system is simple, durable, and forgiving. It can function with dirt in the action, sand in the receiver, or mud packed into the gas tube. It is a weapon built for environments where maintenance is a luxury and reliability is survival. The PKM has appeared in conflicts across the world, from Eastern Europe to the Middle East, Africa, and Asia. It has been used by state militaries, insurgent groups, and irregular forces. Its global presence is not a result of politics or alliances, but of performance. It is a weapon that works in deserts, jungles, mountains, and frozen landscapes. In the evolution of automatic fire, the PKM stands as a symbol of rugged simplicity. A machine gun that proves that sometimes the most effective design is the one that refuses to break. Level 4, Heavy Machine Guns. M2 Browning, DSHK and Cord Machine Guns. The M2 Browning, 50 caliber is one of the most iconic weapons ever created. It is a machine gun that has served for more than a century. Not because of tradition, but because nothing has replaced it. It is a weapon defined by raw power, unmatched versatility, and a design so effective that it remains relevant long after the world around it has changed. The M2 fires the massive 50 BMG cartridge, a round capable of penetrating armor, disabling vehicles, and damaging aircraft. Its impact is devastating. It can tear through concrete, punch through steel, and reach targets at distances far beyond the range of standard infantry weapons. It is not just a machine gun. It is a force multiplier. Its design is simple, robust, and brutally effective. The recoil-operated mechanism cycles with a heavy deliberate rhythm. The weapon's weight, often seen as a drawback, is part of its stability. It absorbs recoil, maintains accuracy, and allows the gun to deliver sustained fire without losing control. Its longevity is unmatched. Designed by John Browning in the early 20th century, it has served in World War II, Korea, Vietnam, the Gulf War, Afghanistan, Iraq, and countless other conflicts. It has been upgraded, modernized, and refined. But its core design remains the same. Because it works. In the evolution of automatic fire, the M2 Browning stands alone. A weapon that has shaped battlefields for more than a century, and will likely continue to do so for decades to come. The DSHK was the heavy machine gun that defined Soviet firepower for much of the 20th century. It was a weapon built not for precision or refinement, but for raw, overwhelming force. A machine gun designed to dominate open terrain, defend fortified positions, and tear through vehicles, aircraft, and anything else that crossed its line of fire. Introduced in the 1930s, the DSHK fired the powerful 12.7 108mm cartridge, a round comparable to the American 50 BMG. Its impact was devastating. It could penetrate armor, disable trucks, damage aircraft, and suppress infantry at long distances. In an era when mobility and mechanization were reshaping warfare, the DSHK gave Soviet forces a weapon capable of countering the growing threat of armored vehicles and low-flying aircraft. The gun's design was simple and rugged, traits that became hallmarks of Soviet engineering. Its gas-operated mechanism was reliable even in harsh conditions. It could function in freezing winters, scorching deserts, and muddy battlefields. Its large, heavy receiver absorbed recoil and allowed the weapon to maintain accuracy during sustained fire. During World War II, the DSHK appeared on the Eastern Front, mounted on trucks, tanks, and fortified positions. It defended supply lines, protected armored columns, and provided anti-aircraft coverage against German dive bombers. After the war, it spread across the world, appearing in Korea, Vietnam, Afghanistan, the Middle East, and Africa. It became a symbol of heavy firepower in conflicts where reliability mattered more than sophistication. The DSHK was not a refined weapon. It was heavy, loud, and difficult to maneuver. But it was dependable, and in the chaos of war, dependability is often the most valuable trait a weapon can have. It earned a reputation as a machine gun that could be trusted to fire when needed. Regardless of conditions or maintenance, the cord-heavy machine gun represents the modern evolution of the DSHK. a weapon designed to address its predecessor's limitations while preserving its strengths. Introduced in the late 1990s, the Cord was built to deliver the same devastating firepower as the DSHK, but with greater accuracy, reduced recoil, and improved mobility. The Cord fires the same 12.7 108mm cartridge, a round capable of penetrating armor, disabling vehicles, and engaging aircraft. But where the DSHK relied on brute force, the Cord introduced refinement. Its redesigned barrel and recoil system significantly reduce vibration, allowing the weapon to maintain accuracy during sustained fire. This improvement is not subtle. It transforms the way the gun handles, making it far more controllable than earlier heavy machine guns. One of the Cord's most important innovations is its ability to be fired from a bipod. This is extremely rare for a weapon of its caliber. Most heavy machine guns require tripods, or vehicle mounts to manage recoil. The Cord's improved recoil system allows infantry to deploy it quickly, reposition it easily, and fire it effectively without heavy support equipment. This mobility gives modern forces a level of flexibility that older designs could not match. The weapon's construction is lighter and more ergonomic than the DSHK. Its polymer components, improved manufacturing techniques, and refined internal mechanisms make it easier to carry. Yet despite these improvements, the Cord remains rugged and reliable. Traits essential for a weapon intended for harsh environments. The Cord is used on vehicles, helicopters, naval platforms, and fortified positions. It provides long-range firepower, anti-vehicle capability, and defensive coverage against low-flying aircraft and drones. Its accuracy at range makes it effective in roles traditionally filled by heavier, more complex systems. Level 5, Advanced Systems, the Minigun and the GAO-19 machine guns. The minigun is one of the most recognizable weapons of the modern era, a machine gun that does not fire like a traditional firearm, but like a mechanical storm. It is a weapon defined by speed, by volume, and by the overwhelming presence it brings to the battlefield. When the minigun fires, it does not sound like individual shots. It becomes a continuous roar, a stream of metal that reshapes everything in its path. Unlike conventional machine guns, the minigun uses an electrically driven motor to rotate its barrels. This design allows it to achieve rates of fire far beyond what a single-barrel weapon could withstand. Thousands of rounds per minute. A level of firepower that turns seconds into decisive moments. The rotating barrels distribute heat, reduce wear, and allow the weapon to sustain fire that would destroy other systems. The minigun was originally developed for aircraft, where speed and firepower were essential. Helicopters, in particular, needed a weapon that could deliver overwhelming force in a short window of time. The minigun filled that role perfectly. Mounted in door positions, it provided suppressive fire that protected troops during insertions and extractions. It could clear landing zones, break ambushes, and dominate terrain with sheer volume. Provided unmatched suppressive capability. Its ammunition consumption was enormous, limiting its use in infantry roles. But when logistics allowed, it delivered firepower that no other weapon could match. The GAO-19 is the heavy counterpart to the minigun, a Gatling-style machine gun that fires the massive 50 caliber round with the same rotating barrel principle. It is a weapon built not just for speed, but for destructive power. Where the minigun overwhelms with volume, the GAO-19 overwhelms with impact. Each round fired by the GAO-19 carries enough energy to penetrate armor, disable vehicles, and damage aircraft. When combined with the weapon's high rate of fire, the effect is devastating. It can deliver dozens of 50 caliber rounds in a single second, creating a level of firepower that few systems can match. It is a machine gun that bridges the gap between infantry weapons and autocannons. The GAO-19 uses an electrically driven motor to rotate its barrels, allowing it to sustain high rates of fire without overheating. Its design distributes heat across multiple barrels, reducing wear and extending operational endurance. This makes it ideal for roles where continuous fire is essential: convoy, protection, perimeter defense, and helicopter support. Mounted on helicopters, the GAO-19 provides a level of firepower that transforms the aircraft into a mobile fortress. It can engage ground targets, suppress ambushes, and protect landing zones with overwhelming force. Its 50 caliber rounds offer range and penetration that smaller calibers cannot match, giving aircraft the ability to engage threats at greater distances. The weapon's design emphasizes reliability. Its feed system is robust, its components are durable, and its operation is consistent even in harsh environments. It is a machine gun built for modern warfare, where threats can appear suddenly and require immediate, overwhelming response. Secret Level 6, Black Budget Weapon Systems. There is one more level in the evolution of machine guns. A level that does not appear in manuals, procurement lists, or public inventories. A level that exists in the margins of budgets, in restricted testing ranges, and in the quiet spaces where technology advances without announcement. It is not defined by a single weapon, but by a category of systems that are rarely acknowledged, and almost never discussed openly. This is the world of black budget weapon development, the place where the next generation of automatic firepower begins long before the public ever sees it. These systems are not prototypes in the traditional sense. They are not experimental curiosities or engineering exercises. They are weapons built for specific, emerging threats, weapons designed to operate in environments where traditional machine guns struggle. Weapons that combine automation, advanced materials, and new forms of targeting into platforms that push the boundaries of what automatic fire can do. One of the most significant developments in this hidden world is the rise of IA-assisted remote weapon stations. These are not the remote turrets seen on modern armored vehicles. Those are the public versions. The black budget variants incorporate advanced sensors, thermal imaging arrays, and machine learning algorithms capable of identifying patterns, tracking movement, and prioritizing threats faster than a human operator can react. The secrecy surrounding these programs is not unusual. Every era of warfare has had its hidden developments. Weapons tested in silence before appearing suddenly on the battlefield. The difference today is the speed of technological change. Advances in computing, materials science, and automation are accelerating the evolution of firepower in ways that are difficult to track, and even harder to predict. What is known is limited, what is unknown is vast, but the direction is clear. Level 6 is not defined by a single weapon. It is defined by a shift, from mechanical firepower to integrated firepower, from human-driven systems to human-assisted systems, from visible weapons to invisible development. It is the level where machine guns stop being purely mechanical devices and become part of a larger network, a network of sensors, processors, and platforms designed to operate in environments where speed, precision, and adaptability matter more than ever. Level 6 is not about what exists today, it is about what is being built for tomorrow. The weapons that appear only in shadows. The systems that shape the future long before the world sees them. In the evolution of automatic fire, Level 6 is the frontier. The place where the next era begins.